Here we have a table of y equals depth versus t equals time for a hypothetical depth versus time function. We want to calculate the average rate at which the function changes. Now we've talked about that, and you know that to calculate the average rate, you take the change in the depth, which is going to be negative 20 centimeters, and divide it by the change in the clock time, which is 10 seconds. So that negative 20 centimeter change over 10 seconds is negative 2 centimeters per second. Let's look here for a minute. Okay, we have this symbol delta. Okay, it's pronounced delta just like what you got at the lower end of the Mississippi. That means a change in something. So a delta y means change in y. Delta in mathematics generally stands for change in. On your home page and in your printouts, you're going to see a backwards apostrophe and a D. That means delta. I cannot put a delta reliably into an HTML document because not everybody has a font set that will read a delta. It would read a D by default, and that would cause a lot of confusion, more confusion than it does to put a backward apostrophe in front of a D to stand for delta. So that backward apostrophe D Y really means delta Y. When you write it out, you should write the delta. Don't write this notation, just read that notation and translate it in your mind into delta notation. Now you see that what we've done here is we've taken a change in y, which is a delta y, and divided it by a change in t, which is a delta t. And we get change in y over change in t, in this case is our rate, negative 2 centimeters per second. Okay, over here we've made that even more specific. The delta y is negative 20 centimeters, delta t is 10 seconds. That's the calculation we've been talking about, and you should understand that by now. Negative 20 centimeters divided by 10 seconds is negative 2 centimeters per second. You can see that we have a delta y between 80 and 62 of negative 18 centimeters, and a delta t of 10 seconds, which gives us negative 1.8 centimeters per second, and that's going to be our rate here. So our delta y over delta t is our rate. This is a very important ratio for a lot of applications, but especially for calculus. We do a lot with this in calculus, more than you would believe at this point. Right now we're just trying to understand what it means to calculate a rate by taking the change in y and dividing it by the change in t.